This is just a little brief introduction into calculus for those people that have been away. And it's nice maybe to compare to something that we know, like algebra. And the fact of the matter is, we know that algebra, we are interested in, often when we're dealing with straight line graphs, we're interested in the gradient between any 2 points. And we know that the gradient between any 2 points is simply the rise over the run, and we can easily find the gradient of any particular line that way. It's not quite so easy with calculus, because calculus is all about curves, and it's about finding the gradient or the slope of a curve at a given point. So we take this point and this point here, and obviously in a curve, gradient's always changing, and so the gradient that is at point 1 versus point 2 is going to be quite different. And calculus enables us to find the gradient along a curve at specific points. That's what it does. Now, if we take a look at the 2 points on this curve, if we move these points closer and closer to each other along a curve, we get this kind of thing happening down here, where those points get closer and closer together, and you get, if you blow up a curve and you zoom it, and those points get closer and closer together, you end up approximating a straight line. And the straight line at a particular point, this could be a very, very small point on the curve. When you have that situation happening, you can draw a line to hit that point, because basically you've got kind of a straight line even though it's very, very small. And when you draw a straight line that hits a curve in a single point, we call that a tangent. And tangents enable us to find gradients along a curve at a certain point. Now, if we put this in context, if we look at a graph, and if we look at the graph from the point of view of a straight line, so the straight line is between here and here, we can find, if we're talking about velocity, the speed, we know that speed is calculated distance divided by time, which is just rise over run. And in this case, it's up 1, 2, 3, and over 1, 2, 3, and so it's a gradient of 1. It has a slope of 1. And that just means that it's going 1 meter per second if you're dealing with distance-time graphs. Now, when you look at the second half of this graph, which is a curve, it's a little bit more of a problem. So if you look at seconds, if you look at the 6th second, which is right here, and you wanted to figure out at that particular point how fast something is going in context, so you want to find what the instantaneous velocity is at this particular point. Well, we need to use calculus to do this, because we don't know what that is, and this is where calculus comes in. And what we do is we think of drawing a tangent, a straight line, to that point that hits just at that point. And if we can find the gradient of the tangent that hits at that point, say 6 seconds, if we can find that gradient, then we know how fast somebody is traveling, or the velocity at that particular point in the context of the question where you're dealing with distance and time. So really differential calculus is simply trying to determine the gradient, or if it's in context, what the gradient is at this point, an instantaneous moment in time, what the gradient is, what the rate of change is in that second, in that moment, in that infinitesimal part of the curve. And we can do it with tangents, and we do it with differentiation. We do it with what are called derivatives, and we'll investigate those a little bit later.